And today we're going to kind of answer a lot of questions related to our heat mitigation system, which is what comfortably puts our upper receivers into a auto rifle LSW type role, which allows you not to have barrel swaps and all this other fun stuff, and basically builds this rifle into a category that can handle that role very easily. There's a lot of questions regarding of like fitment. You know, why can't I just stick this on anything? Why can't I buy it on its own? And we're hoping today we're going to answer some of those questions in this hopefully cut shot format of me doing my best to one take a bunch of stuff with my editing. Thanks to Faith Outdoors, I'm using their little green screen room. Probably not going to do anything on the green screen. I'm not that technical, but it is a nice clean background and we got good lighting so I can show you all this stuff. We will zoom in on the table and I'll show you some different reasons and design cues and explain the system more to help answer those questions, which of course you can still reach out to us at info@redrighthand.llc.com, and I'm happy to answer that. I answer those emails a lot. This goal is help kind of visualize a lot of the thinking, the modes, and the reasonings behind why this is what it is and where it's currently sitting and where it's currently going. So follow me on this journey here today and we'll learn something. This is a traditional government profile barrel. Traditional government style gas system with a low pro block here. This is just an example. It's for educational purposes here. So the thing about these barrels is they're light in the center here for you to be able to carry these things all day. They are not meant to be sustained fire, and there's tons of evidence out there, and there's all the docs you can find everywhere online if you do a little bit of research of where these barrels fail and how quickly they can fail when they start getting shot a lot in a real quick hurry. Typically we see bullets where the barrel likes to burst on government barrels is right here just before the gas block. They have this really weird taper that comes down right here. They did that obviously for weight savings, but it's real thin. And typically when you see a government profile barrel burst because it's gotten too hot, if the gas tube hasn't failed, it's gonna fail right here. That's a problem. So when you try to use a government style profile for a auto rifle, for example, to save weight or something, you are endangering yourself because you're using a barrel that's just not meant to do that. All the heat is gonna build up right here and that's where it's gonna fail. So traditionally too, they have a bent gas tube. The government wanted the triangle handguards back in the 60s, so they eventually came down with this height, which has just kind of remained in the marketplace for the most part. A lot of people don't realize though, the straight gas system was actually around first. Of course though, the government likes to ruin everything. So by doing this, they have these two sections of bends. Well, heat likes to build up in a bend because it has to slow down. Well, if it's slowing down, it's going to be building up more heat in these corners. So you can see that in a lot of FLIR footage when people are dumping lots of rounds through these. And they also like to fail right here about an inch or so in this region behind the block because this gets really, really hot. This is obviously where all the heat's at. This is where air is interacting with this first. So it's gonna help thin that material out as it gets really, really hot, and usually they'll burst here. The normal M16 is designed to fail before technically bursting this barrel. However, gas tube material is really good these days, and people are able to actually burst their barrels before they burst their gas tubes half the time. So it's not designed to handle that role. It's not meant to be a fully automatic machine gun. It's not meant to be an auto rifle where it's doing some support by fire or a little bit of cover fire, grazing fire, whatever the hell you want to call it. At the end of the day, this is meant for fighting carbines and for infantry style shooting. It's not meant for lots of fighting. So when we built our uppers, we went with H-bars. And here I'm going to show you a couple of examples of our H-bars and why they're superior to using this system. So when it comes to H-bar barrels, there's a couple different camps, but there's two main types at this time and age. We have the classic, what's called its 980 profile, from here at your gas block to your extension. It's almost 1 full inch thick. So most people like to refer to these as 1 inch thick because it's within 20 thousandths. It's a very thick boy. Standard 750 gas journal out the front, standard M16. This kind of helps the wieldability of it, but you have all this mass right here behind the barrel. Now, because there is no thin spots, barrels like this don't burst. They can't. If you burst this barrel at this section, I don't know what you did. Needless to say, they can handle a ton of abuse. They're also thicker and they're heavier, so they have a lot of thermal mass. As you heat this metal up, it takes longer to heat up, but way longer to cool them down because it's so much more metal. And it only has the surface area of the 980 profile. So when you get these hot, they typically stay hot longer. Now they will have increased performance up to that point compared to the traditional lighter barrel, where once that thing gets hot and starts getting cooked, your accuracy starts to degrade a lot quicker than if you shoot an H-bar. However, the government profile will cool down faster on its own because, well, it's less thermal mass, it has less material. So this is your traditional classic 980 H-bar. We like these, we use these on our Recce LMG. The other big factor is this weighs about 3.3 pounds, and weight is important in an LSW as far as like your recoil management and all that fun stuff to maintain your cones of fire. The other type of H-bar, this is a little bit newer, and it is actually the SOCOM profile. Everybody likes to say government SOCOM or whatever, and they literally market this trashy government profile as SOCOM. This is not the SOCOM profile. This is the SOCOM profile. So to fix the problems with the bursting government barrel, Colt made the SOCOM barrel. That's where the M4A1s and all that stuff come from, where they basically put a 980 profile. They tapered it down from its standard diameter out here, which is 980, and then come down to 875. This does not have any area for burst, just like on this barrel. It is a bit lighter overall than these heavier barrels, the original H-bars. So you'll notice we use these on our IARs. This is lighter than this barrel, so it kind of serves the IAR role better. These don't burst because there's no thin spot in them. In fact, Colt used this barrel a lot for their IAR program, and it's been widely used, and it just goes a very, very long time and doesn't blow up. So, when they pair it with the standard traditional gas system, again, the thing that will fail when you set up a barrel, like if you build your own IAR at home and you're still using this gas system, you're still leaving a massive, weak, fatal flaw in that gun, because now your gas tube's gonna be the part that fails. It's not very easy to switch this out, especially in the field. Once it goes down, it goes down. You can kind of mitigate some of that using like an Inconel gas tube, but once they start to droop, you start having gassing issues. At the end of the day, it's still not necessarily the best gas system to go into that role, because now your barrel definitely can handle everything you throw at it, but your gas system is now the weak point. So we picked the right profile, and we are going to show you how we mitigate the heat issues that you get from getting a barrel really, really hot. And then we're going to talk about why our gas system combined with the HMS comfortably makes the LMG and IAR by Red Right Hand with the HMS system a very comfortable auto rifle, LSW, whatever you want to call it. It puts that upper into that category of it can handle it all, and it's built to do it. And that's why purpose-driven, purpose-built is better than just trying to hosh-posh some stuff together or ask something to do something it's not meant to do. So now we're going to show you the HMS system paired with the H-bar. So when we set out to build the Recce LMG, we put a lot of thought into what we were going to do to make this a very successful, purpose-built upper receiver for the role we were building it to. 980 H-bars are great, and like I was telling you, this is a big mass of metal. Problem is, once it is very hot, it's harder to cool down. So versus just leaving this bare metal, we developed the HMS system. So the HMS system, heat mitigation, is a series of 6061 aluminum heat sinks. In fact, there are 4 major size ones on each barrel, and then we have a end cap. So this end cap kind of determines the overall length, dealing with the type of barrel nut that's used. These basically will stack on the entire barrel all the way back to the barrel nut. And then we'll go all the way forward right to the edge of the profile by the gas port. So we wrap this entire section, I should say wrap, we take these parts and we press them onto your barrel. Now, the thing about 980H bars and when we source stuff and buy stuff and have stuff made for us is that there's still going to be a tolerance on this section, and it's not always going to be exact. That's manufacturing. Everything's going to have a plus or minus. We make these very, very tight. In some cases, I have to open them up on a lathe. Other times we heat them and press them, or other times they just press. Just depends. So this is why you won't see the HMS system as it currently sits available for you to install at home. I don't want you to damage your stuff. I don't want you to damage the HMS system. And at the end of the day, I would love to just put it on your rifle for you. And that way I can guarantee it and prove you that it will always do its job because I put it on. I know it's good to go, so we can stand behind our product. By doing this, we have quite a bit of material here. So this material is finned. It comes down, the still wall thicknesses are still about 60 thousandths, and it takes the overall diameter from 980 to 125. So it basically ups the giant, it makes your mass bigger underneath your handguard, but it is adding a ton of surface area and it is adding a ton of cooling area. 6061 naturally draws heat from steel. It's a process of thermodynamics of the lighter metal will draw the heat quicker away and shed the heat faster than the heavier material. So by taking these heat sinks and putting them on this barrel, we're drawing heat constantly from the steel. So these will get hot. They'll get super hot. Your rail is going to get very hot, but it's all aluminum and it's shedding that heat way faster than the barrel steel. So the inside of your barrel is remaining cooler than it would if it did not have this system on it. In some of our different tests, depending on environmental factors of when, time of year and stuff, we're seeing about 30 to 40 degrees difference on the internal of the barrel during the same type of strings of fire than if we did not have this. That's significant. That does a lot for your barrel. We have our examples here that have 14,000 rounds on them, almost either full auto mag dumps or nonstop shooting, and they don't exhibit fire cracking. Fire cracking happens when you get a barrel too hot and you actually start burning the metal. We don't do that because heat sink system is yanking the heat out of the barrel as fast as it's being generated in most cases. And even if it does, it's still drawing it at a consistent rate. So even if you get a little bit hotter, it doesn't matter. This heat sink system's doing its job. It's going to be drawing the heat from the most important part of your gun, which is your barrel. This helps you maintain accuracy longer, reliability longer, keeps your cones of fire and shooting tighter because the barrel's not as hot. And since we're pulling heat from the barrel, we're pulling more heat out of the whole process. So that it lowers its overall operating temperature and allows you to shoot longer, harder for a lot longer than you would if you did not have this system. So that's why we went out and developed it. These are 6061 T6 aluminum. They are CNC machined to a tolerance. They are Type 2 anodized, so they're black, so they hide underneath your handguard. That's where all the magic happens. You can't quite see it. Some people go, oh, it's just a 20-inch gun. There's a lot underneath the hood here. So we put these on the barrel, and that allows us to operate very comfortably in an auto rifle roll and LSW roll without having to do barrel changes, because at the end of the day, your barrel's just not getting to the point where you'd have to technically remove it. Also, it's pretty unrealistic for a rifle that's set up to be like this to be considered like a 240 or a 249 where you're just belting ammunition, which you're just not doing. Every time you're doing a mag change, you're exchanging air within the barrel with an open bolt, and then you're dropping the bolt back down, so you're pushing more air through it, and the heatsink system the whole time is drawing heat away from the critical components of your barrel. So that's what the HMS system is. It's It's not necessarily something that the average person can install. We are working on a version that will be a more DIY, but when you start reaching into the more general, we try to like make a heatsink system that's gonna work for the most amount of people. You lose some of that, what do you call it? Like purpose drivenness, right? Like this is built and calculated to work with this. If you did a lighter version, it necessarily is not going to be as effective as the original version, right? Because this stuff was well built to do it. So once we've coated this barrel in aluminum heat sinks, we've increased its surface area and its cooling ability. Now how do we manage getting the gas tube over the top of this giant 125 diameter, and as well as how do we build a gas system that can handle the fact that this barrel now is not going to burst because it's really thick, but it's also cooling faster. So we came up with our other solution, which is with the rifle speed and our heat sink coil that goes over the gas tube. So let's talk about that. So overall, once installed, the HMS system is 1.25 inches in diameter now. We went from a 980 profile to a 1250. Big boy, thick system. We have to clear that, and the solution is going to a straight gas tube. Now, the straight gas tube is going to offer some good advantages, right? Now that we don't have those kinks, we have just a straight run. There's no area for it to slow down and build up in. It gives you a really consistent push to the rear, which is awesome. It's just better on the carrier key, in my opinion. Eugene Stoner really liked it, and we see this system utilized by like LMT, CAC, which is the actual Knights Armament Company, and a handful of other high-end builders because they know that this is a very good system. Rifle speed gas blocks utilize straight gas tubes, mainly so they can clear their adjustment method, but it pairs really well with clearancing the gas tube above our heatsink system. Well, at the end of the day, we still use a stainless steel gas tube, and a lot of people are like, oh man, the stainless steel is going to burst. It could, and it would if it wasn't had a heatsink built into it. So we make a heatsink coil here. This is made out of a nickel copper alloy. So copper and stainless steel do not like each other. They actually will erode. So we have a nickel coating over that copper, which plays great with stainless steel. One more thought about this because it helps us with the weathering and protection of not only the stainless steel, but also the coil itself. If you leave copper exposed, it turns a bunch of crazy colors and it erodes. This doesn't do that. Best part is copper is just like aluminum on steel. It draws tons of heat and handles heat extremely well compared to just the stainless steel tube. The stainless steel tube is going to hold up for a lot of heat, but now it has something helping to draw heat away and adds a ton of surface area to this gas tube. Now, this is one of our demos here. You can see ever so slight discoloration, barely any. In fact, we don't really see heat discoloration in our gas tubes with this coil installed because it draws so much heat from that tube so quickly because the tube is a thinner material, and you got to think all of a sudden how much actual material we just added on top of it to draw heat from it. And that in itself is a coil which has the ability to pass air through it and heat up and cool off real quick, so it's yanking all the heat out of that tube, which is awesome because it also reduces the amount of heat going back into the receiver in those actual gases because it's cooling those gases down, if you think about it, as it's coming to the rear, and it's cooling the tube off. So now we still have a normal gas tube, but we've made it just absolutely run and run and run and run. It's extremely comfortable being an auto rifle roll now because it is actively being cooled and it's cooling the system down and it's doing its job. It's extremely effective. So when you compare our normal heat mitigation system for the barrel and then we add our gas tube heatsink coil here, we are just absolutely giving this upper every ability to shed as much heat through its entire cycle as much as possible and allows this upper receiver to just be an auto rifle and run in an LSW roll and keep cooling itself no matter how much rounds you put through it. A lot of people ask me, hey, shoot it till it explodes. One day we'll probably do that. It's an expensive endeavor. It's going to take a ton of ammunition, and obviously I'd like to do a nice big production of it. However, also YouTube won't give us any money for promoting that, so it's kind of we're spending that money, and that money's not really coming back as far as like monetization or anything like that, which I'm not trying to get rich on YouTube. I'm just trying to explain the product. But put it this way, in every realistic roll, we've done 500 rounds non-stop, we've done 300, 400, we've had guys do 750 rounds in like 40 minutes. The ECT guys did like 1,300 rounds in a couple of hours. The guns run. They don't get too hot, they don't burst, they don't malform or discolor or anything like that. The system is doing what it's supposed to do, and that is drawing the heat away from the system. Next, we're going to talk about the rifle speed gas block in its advantage here of also how it's also maintaining this rifle very comfortably, and is actually a way of maintaining our heat as well as our ROF and everything else. And then we're going to talk about the rail. So on the original Recce LMG series and the IAR V1s, we use rifle speed gas blocks, and I'm a huge fan. Not only are they completely toolless adjustment, they allow you to dial this system like right on the fly. And the best part is we run a really large gas port, and that's by design. And the rifle speed allows us to just tune this into whatever we want. And there's multiple size plungers, and the best part is it adapts to anything in the back half, bolt carriers, your buffer systems. In our case, we have machine guns, so we can dial in the rate of fire really easily. The rifle speed allows you to cut the system down, which is also cutting the amount of gas going back to the gun, which is allowing more propellant to like leave the barrel versus go back towards you, the shooter, and add more heat to the system. So it definitely helps control the amount of heat going through the gun, as well as it slows the gun down shooting. Okay, so if we make a slower rate of fire, you are conserving ammunition better, you're staying on target better, but you're also inadvertently keeping the gun cooler because you're not just putting round after round after round. There's more time. Now, of course, this is obviously nanoseconds and all that fun stuff, but all that adds up. So that is one reason why we really love the rifle speed. It did literally everything we needed to. These are 100% duty grade. I have 40,000 rounds between multiple examples now in my shop that rifle speeds don't fail. They just work. You put a little oil on them and you call it a day. They just run, run, and run. Every single one of them is double dimpled and bomb-proof install pinned. Like, they just don't go anywhere. And the best part is it just gives you such an operational envelope of where you can dial this rifle into, but it has that ability to also help manage heat. So all this pairs really, really well with the HMS system, and just in general, it just allows this rifle to be very comfortably put into an auto rifle roll. This is purpose-built, purpose-driven to do just that. Now, real quick note here, this is the IAR using the good old H-bar SOCOM profile, and because this barrel is thinner, right, it's an 875, the outside diameter is still 1.25 inches, okay, but the inner diameter is smaller, thus the heat sinks are actually bigger on the IAR, which is good, right? Because remember how I was saying this barrel is going to heat up quicker than this barrel? Okay, well, when you add more heatsink material to it, the reduction on the IAR is absolutely insane. We had one day, an example, we had like almost 85 degrees difference. It was wild. Obviously, I don't try to advertise that this one can cool that fast, but it has in certain situations. But in the end of the day, again, we're pulling so much heat out of the barrel, this upper is sitting extremely comfortable in that roll. So you can see this one's been shot a lot. Wow. Super crazy color, right? Not at all. It is literally completely set up to run as it should, and it just stretches over it. It's just It's just a coil, guys. And that coil and the material that it's made for just pulls the heat out of that gas tube. This upper's been mag dumped nonstop and done 500 plus rounds in an afternoon. And well, afternoon as in a couple, anywhere from, I think it was like 30 minutes. I think we did like 500 rounds on it. Didn't do anything again. It's just constantly drawing heat. That's why we set out to make the HMS system, because now we can make this rifle comfortably live in the roles that it was built to do. So this video is starting to run a little long, guys. I appreciate you sticking around. Hopefully this is answering a lot of questions. Last reason we're going to talk about, and this is usually why people go, well, why can't I just put this on any upper receiver? And like I think now people are starting to realize this is an 1.25 inch thick, which if you have a 1.3 diameter inside, you're going to have 50 thou free float, but you're not going to have room for certain type of rail systems. Skinny M-lock rails are usually a 1.3 diameter. You can fit this under there, totally clear it, or free float. You cannot install any of your M-lock accessories onto that rail. Also, you put your hands like right on the heat sinks, and then of course, the rail being aluminum is going to draw heat from the other aluminum, so they can keep doing their jobs closer to the source, and it's going to air off. Now, we've made a couple different versions that allow you to do that with an M-lock, but they all have to be a standoff style. So the quad rails are perfect, right? Because the quad rails here have the right diameters, but then they step off, obviously the rail system steps off of all the heat that is in this nice location. This not only protects your hands, but this is a giant heat sink on its own. Look at all the surface area. Now you can put some rail covers on this, it's not gonna hurt anything. At the end of the day though, this is drawing a ton of heat as well away from the heat sinks. So some guys are like, man, this handguard got hot. Yes, that's fine. It'd rather this be hot, these be hot, but the inside of your barrel, the inside of your gas tube, the inside of your operating system is operating cooler because all the heat's being pulled away. So, you know, that's why you can get a Klein Machine carry handle. You can run yourself some good covers or a vertical grip, and wear gloves. I mean, you're in an LSW gunner position, you should be wearing gloves anyway. But this is in itself drawing heat out. We used the M-lock, not the M-lock, these quad rails from Midwest Industries because, I mean, they're great. They come in the longer lengths that I like because we like to be able to leave a little bit of the gas control knob out so you can access it and clean it in the field and be able to maintain it very easily without having to remove your rail or have to like dive in. That's the reason why on the LMG and the Recce series IARs, they're at the lengths that they are so you can access the knob, which I found was way more important than burying it inside the handguard so you have a longer handguard. At the end of the day, that is, you know, for the role this rifle's built into, that should be more important than having a rail because you think it's aesthetically pleasing. It is legitimately at that point built for that purpose. The other nice thing about Midwest Industries is this bottom rail is actually one solid thick extrusion piece. It's not like hollow like these. It is basically a giant diving board that they have had to cut holes through and through, but this is all one giant section of aluminum. This is an extremely rigid section to put your bipod on. Okay, you can put a lot of mass into this because you're not going to flex the rail. These thinner M-lock rails and stuff, they just can't handle that stuff, guys. They're not meant for it. They're meant for fighting rifles and lighter weight guns. This rail is literally built for like duty use to go to hell and back. It's a super strong rail. So the reason why we picked it, not only does it have this heat sink property of being a giant rail system that also stands your hands off, you could use any accessory known to man. Everything still works with Picatinny rail. And you have this giant section of metal, well, aluminum in this case, that is just ridiculously rigid. That's what this was built for, to be a purpose-built system. So, I mean, this is kind of a little bit of an overview on like the whole rifle itself, but you could see where this was driven, all these other decisions were driven by the fact that we built the heat mitigation system. So I know this video is getting too long at this point, so I'm gonna stop here. But you have any other questions, feel free to reach out to redrighthandllc.com. Come check out our products. I have a lot of this written up on the website, but a lot of people like to just listen, or a lot of people want to see the visuals. So we're going to do that. I kind of have this opportunity to use this green room. So, hey, we're going to be making more videos like this, behind the scenes, explanation videos, showcasing the core designs and the core aspects of all this. Thank you for joining me today. Please go around YouTube, check out all the other YouTube creators that have made videos involving our upper receivers and giving them some love. If you're interested in Recce LMG and IAR or any type of build, we offer rifle speeds, we offer piston driven, we offer non-adjustable systems for certain uses. We have quite a plethora library of auto style rifle uppers to kind of like suit everybody's needs. But at the core, you're going to find our heat mitigation system being employed in those upper receivers, because we believe that that's the best way we can bring this rifle into the 21st century, make it a 2023 product. The Recce LMG is my modern day take on making the original Colt LMG. So it has a lot of advantages. I hope today this helped explain some of that. And again, feel free to check us out at redrighthandllc.com. Thank you for watching.